This brief video demonstrates using Kornucopia ML for analyzing runtime monitor logs created by the Spectral Dynamics VIDAS high-speed test measurement system. Kornucopia ML for use with MATLAB is truly the horn of plenty, with its large number of tools to help you analyze real-world, complicated data. These capabilities are applicable for the analysis of both physical test data and simulation results. In this video, we will concentrate on Kornucopia functionality for processing runtime monitor logs created by Impax-SD software that runs in the Spectral Dynamics VIDAS system. Consider a typical physical testing scenario where you are making several high-speed, short, transient measurements with the VIDAS system. The software running on the VIDAS system is Impax-SD. The measurements you make occur occasionally throughout the day. You also need to record slowly changing variables such as daytime temperature over the duration of the day. We do not need to capture this data at high sampling rate. Slow and frequent sampling will be adequate. An easy way to capture such a slowly changing variable is to use Impax-SD's runtime monitor log, also known as the real-time monitor or RTM. The RTM interface in Impax-SD stores average and peak-to-peak values of requested channels into a log file. The slider bar on its GUI allows you to control the time increment for writing the data to the log file. Relative to the typical high-speed capture of the VIDAS system, you can write with much longer time increments, such as 2 seconds. The RTM is intended only for slowly changing quantities, as it has no AA filtering applied to the log data relative to the slow capture rate. The RTM logging can be started and stopped as needed. By default, the log file keeps appending. Presented to the right is a typical RTM log file. The challenge for the user is that the data of interest is grouped by the timestamp. This makes it difficult in most software to create a plot of temperature versus time. Fortunately, Kornucopia ML makes processing an RTM file easy. We are now in the MATLAB environment to demonstrate how Kornucopia easily processes the RTM log file. First, we use Kornucopia's SD Impax RTM import function to read and automatically parse the RTM file of interest. Using the Kornucopia variable viewer, or MATLAB's variable editor, we see that the variable RTM_raw contains a table that provides several items of interest, including k-units tables holding the average, peak-to-peak, and polarity information from the log file. Exploring the average column from the main table, we see that Kornucopia has parsed and organized the data into an easy-to-use table for plotting or other types of calculations. Lastly, we use a few additional commands to make a plot of how the temperature varied throughout the day, where we've also leveraged Kornucopia's units capabilities to easily convert the elapsed time from seconds to hours. With Kornucopia ML, you get faster data analysis with greater understanding, because you get to work with all your data, numbers, units, and text. This enables flexible and more accurate workflows, giving you and your team greater confidence in your results. There are tools to process messy and noisy data for solving important real-world problems. With efficient plotting that has automatic labeling, you can quickly and clearly communicate your results. And our real-world template examples help you jumpstart your solutions. This is all supported with a teaching help system that allows you to learn more and grow your value. Kornucopia ML improves the speed, precision, and effectiveness of both you and your team.